All right, well, good morning, everyone, and welcome back to another exciting day of mathematics. Woo-hoo. Warm-up number 3 is on the screen. Number 1 is just instructions as to just to keep the structure of the day going, but I want you to do numbers 2 and 3 really quick. It reads, find the sum, difference, product, and quotient of negative 18 and 23 Michael Jordan. And number 3 is find the sum, difference, product, and quotient of negative 7.5 and 2.5. And then we're going to continue with our lesson. We're going to do some setup for our notes, so we'll get to that, and I'll give you more instructions on that. But for right now, let's get started with that, please. Copy and go. All right, so with that said, look at number 2. It says find the sum, difference, product, and quotient of negative 18 and 23 Michael Jordan. Share with your neighbors, see what you got for those 4 operations for number 2. Then I'll call on someone. All right, so let's get started. I'm going to start with the sum of negative 18 and 23. What you get for the sum, Jaden? 5. Hands if you got 5. That is correct. Thank you. Let's go with the difference of negative 18 and 23. JP?
Negative 41.
Negative 41. Hands if you got that. That is correct. Let's go to the product now. Product of negative 18 and 23. How about Alyssa? What'd you get for the product? Negative 414. Hands if you got that. That is correct as well. And last but not least, we got the quotient. Alyssa, pass it to someone. Negative 0.78. I'll take that. That is correct, by the way. Now, if you got 1 point something, is because you inverted the numbers. Look up to the screen. The first number that they, oh, my bad, sorry. The first number that they give you always goes inside of the division. So 18 divided by 23 Michael Jordan. Since it doesn't fit, you add a decimal, you add a 0, and then that's when you start with 7, and so on and so forth. And at the end, you look at the symbols. If these two, when it's division and multiplication, are different, the answer is always negative. Okay? All right. Are we doing good? So on these kind of expressions from 1 to 5, how comfortable do you feel with these? 1 being the lowest, 5 being the highest? Yeah. 5, 5, 5. Yeah. 4s? Yeah. All right. And for number 3, I'll leave that for you. I'm pretty sure you got all those correct by now. All right. So let's see. I'm going over the structure of the day to make sure we understand the process. What is the first thing we do? The warm-up. What is the second thing we do after the warm-up? Copy the agenda under the warm-up. So copy the agenda that's on the screen, and it reads agenda, warm-up number 3. The lesson's still on number sets and expressions. We started it yesterday. Today we're going to finish it. And tonight's home play is 6 problems, which is to simplify expressions, and then we adjourn. Okay? Copy that, please. So let's see. Started with a warm-up. Copy the agenda. the very next thing, I usually ask you for the home plate from last night. Is that correct? But before you take it out, this morning they gave you your Chromebooks. Is that correct? No? Okay, some of us, we got our Chromebooks. So for the Chromebooks, there's two things. Number one, you need your login information, and also you need the information for Canvas, which is instructor. So check this out. Look what I'm going to do. For your Chromebooks, you need your student ID with @student.imperialusd.org in order to log in. However, if your ID is only 6 digits, you need to add 2 zeros at the beginning. And some of you are like, okay. So in order for you to be ready when you get your Chromebooks, those of you that don't have it, get your phones out really quick. I'm going to allow you to get your phone out. Take a picture of that screen, and I'm going to go over one more screen so you can take a picture of that screen as well. All right. Now, right now we don't need our Chromebooks. I'm just giving you the information that you need for your Chromebooks, which is there. All right, here goes the next screen. Take a picture of that. That's for Canvas. So if you can't log on, just follow that process. It should allow you to log on to Canvas using that. Okay. No, because we need to get going with a session. Okay. So you got the information? Yes. All right. So at this point, go ahead and put away your phone. If you missed any of the information that's being recorded on the lesson, just go to the YouTube channel and revisit that, okay? All right, so put away your devices, please. Now, once again, like I've been telling the other classes, I have very good vision. Even though I'm looking down, I know that you are on your device. Even if I don't tell you anything, I'm trying to stay focused on my lesson. But it is distracting to me when I see you distracted on your device. So please, pretty please, put those away. So, with that said, home plate from last night. Reminder, materials needed. Make sure you get your materials for this course, because once we get started with Algebra 2, it's going to go a little bit faster, okay? So, yes. Yesterday? Yeah, as soon as you can get it, okay? So if you're like saying, well, I haven't got my stuff yet, Mr. Q, because we're waiting for the weekend, or, my bad, I'm waiting for the weekend, Mr. Q, to mow the lawn and wash some cars and get some cash. Oh, yeah, there you go. That's good, right? Right? All right, so previous home plate. Get that in front of you, please. Of course, everybody did it, yes? Oh, yeah. All right, let's start slow. I'm going to start slow. Okay, so I'm going to start with number 2. Look at number 2. And I want you to share with your neighbor what you got, see if they have the same thing. All right. Thank you for sharing. What'd you get for number 2, Jose? -2 is correct. Now, let me go over the process to make sure we got the process down. What is the first thing I asked you to check for? Addition throughout. Let's see, is there addition here? Yes, 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 and yes. What is the second thing we stand for? 0 pairs. Are there any 0 pairs? Let's see, 6 and -6. Anything else? No. Therefore, we combine like terms. -4 and -5, that's -9. Plus 7. Therefore, can 7 of these cancel 7 of those? Yes, and we're left with -2. Okay, good start. All right, next. Now that we got warmed up, let's go to number 3. This one's going to be a little bit funner. Yes, that's my word, funner. Check with your neighbors, see what they got for number 3. Number 3. What'd you get for this one, Delilah? What'd you get for number 3? -2. That is correct. You're like, what? All right, here it goes. I'm going to go one step at a time. What do we check for? Addition. Is that correct? Look at these two numbers. Is there addition in between? No. That means this changes to addition with the additive inverse property, right? Which means, what is the opposite of a positive 5? -5. I bring down the -2. Continue. Addition. Yes. There's a subtraction here. This changes to addition. This positive 4 changes to what? -4. Bring down the +5 plus -3. This changes to addition. What is the opposite of -4? 4. Now that we have addition, we check for what? 0 pairs. Are there any 0 pairs? -5 and 5. 3, -3. -4 and 4. Answer, -2. Woo! Let's go. My goodness. Okay. Anyways, now that we got warmed up, look at number 7. And check it out with your neighbors. See what they got for number 7. Number 7. All right. Let's see. What do we get for number 7? Alessandra, what'd you get? Plus what? In any order. Look at them. In any order. Hands, if you got something like that, in any order. That is correct. Let's go. Let me double check the work. Ready? What is the first thing we said before we left that we needed to do to this one? Distribute. Is that correct? So we get 8x plus 4y. Bring down the plus. Bring down -5. Bring down the plus. Bring down the -2y. Bring down the plus 3x plus 2 plus 6y. I'm going to go one step at a time. Here you go. Start with the y's. 6y and 4y, that's what? 10y minus 2y. There it is, 8y. Next, let's go with the just the integers. 2 minus 5. 2 of these cancel 2 of these, and that leaves us with -3. And last but not least, 3x plus 8x give us 11x. Anyways, from 1 to 5, how comfortable are you with these so far? Yeah, we got some 5 4s, okay. All right, so that was last night's. You keep that. It's my gift to you. Copy tonight's homework. Only 6 problems. Copy that, please. No. All right, so set that aside, and also the signatures for your syllabus. I'm going to give you an extra day. So I'm going to pick those up tomorrow, okay, especially for those of you that forgot. Make sure you get it signed tonight. I'm picking those up tomorrow. Tell your neighbor what I just said, please. All right. So signatures tomorrow, okay? So now that we got that out of the way, I'm going to go ahead and recap what we did yesterday and continue with the lesson, okay? So turn to the lesson from yesterday where we started. And I usually start my lesson with an objective, and the objective from yesterday was I can simplify algebraic expressions. I can simplify algebraic expressions. I can simplify algebraic expressions. So if I was to ask the question, what is the concept for today? Of course, you would look at the objective and you would know. So tell your neighbor the concept that we are still on since yesterday. What concept are we covering today? All right, just in case you're confused, check this out. I asked the question, what is the concept of today? That's in green. Therefore, my concept is algebraic expressions because it's also in green. And what have we been doing, and what are we doing with all that? Well, we are simplifying, okay? And I'm trying to hammer this. Today's going to be actually the first day that I do a formal introduction to some of the Algebra 2 things that you're going to cover. Okay, we're not fully into the Algebra 2. We're just doing a full review first, and then we're doing then a quick introduction of the sets today. All right? So, all right. So, did I introduce the objective? Yes. Okay, from there we went to, and I said, writing utensils down, look up to the screen, and I said, expressions cannot be solved. We covered that, yes? We can do three things: translate them, evaluate them, and then simplify them. Is that correct? And that's pretty much what we covered yesterday, because we were going over other stuff the previous night, home play and so on and so forth. So, to continue our lesson, on your Cornell notes, check this out. Let me show you what we have. Your page should look something like this. And then it's got the that red line going like that. I asked you to draw another line down, 4 lines up, and then you do a cross, and then we write our objective right here. Is that correct? Then we got our name, date, period, okay? And this column is the column for Q's or questions, yes? All right, so this is what I need you to do. I need you to sketch a table almost covering half the page or maybe a little bit less, but it has to be, watch, like this. 2 big columns and then a small box at the bottom, okay? Let me move this down a little bit. We don't need a lot of down here, so a smaller, like so, okay? Now let me give you what this looks like in real. Here it goes. Should look like that. All right, so copy that table, please. I'll give you some time. So as you're finishing your table, I specifically made it like this. I made this table up, Mr. Q. Yeah, I got skills like that. But notice there's 2 big columns, a big column for real numbers and a big column for imaginary numbers. Now, when I used to teach Algebra 1, I used to introduce imaginary numbers. Hopefully your teacher did. If not, today's going to be a formal introduction to that, okay? However, I do want to recap our real numbers to make sure we understand what we're talking about with real numbers. Now, real numbers we've been dealing with ever since elementary, even before that, okay? So I'm going to start at that column, the column of real numbers, okay? So real numbers is broken into 2 subgroups. Those are called rational and irrational. Label that, please. Rational and irrational. Right now I'm on the column of real numbers. I'm still not in the column of imaginary. Okay, so here we go. Let's start with real numbers, but I'm going to focus on rationals only, okay? Rationals, we started when we were in, I don't know, preschool, even before that. And some of you used them in preschool when you would run to the swings. Remember that? You ran to the swings. You wanted to beat everybody to the swings. I'll race you. Remember, you got on and what did you say? Ready? Let's count it off. -1, negative, no. We didn't start counting negatives. We counted with what? 1, 2. So the first set of numbers that we learned for real numbers were counting numbers. Write that in there. Counting numbers start with 1, 2, 3, 4, 5. And this is just a recap of something that we've covered ever since we started with math. Second set of numbers are these same numbers, but now introducing the number 0, which are called whole numbers. So now we start with the number 0, including now the counting numbers. 1, 2, 3, 4, 5. Pretty straightforward, yeah? The next set of numbers are the numbers that gave some of you a lot of problems. No pun intended. Get it? A lot of problems. See what? Anyways, those are called integers, which means they're the whole numbers, but now including their opposites, which means what? All the negatives. That is correct. So now we have 0, 1, 2, 3, and on, and all the negatives of those. Okay? So, but notice that I only wrote them in the column underneath rational numbers. But rationals are still part of real numbers. But why are they called rationals? Here we go, in case some of you get confused with all this. Rationals comes from the root word ratio, which means fraction. Which means what? Fraction. Rationals are fractions, or they can be written as fractions, such as this. If I was to ask you, take the number 3, write it as a fraction. Well, you write what? 3 over 1. What if I asked you to write a fraction with 2 and 3? You would write what? 2/3, and so on and so forth. Okay? So these are called rational because they can be written as fractions. Rationals because they can be written as? So if that's rationals, what do you think irrationals are? They can't be written as fractions. Write these in there. Pi, square root of 2, phi, and e. All these numbers cannot be written as fractions. You're like, I thought pi came from a fraction. No, it did not. Pi is basically, it's a formula. We'll get to that later. And you probably already covered it in your previous classes. Square root of 2. And remember, pi doesn't stop. It's 3.15, it just keeps going. Phi is what we call the golden rule. We'll talk about that later. And e we're also going to use later in the course. Okay? So, let's see. All of these, including the irrationals and the rationals, are called what? Real numbers. All of these are real numbers. But the only thing is that there are two categories, those that can be written as fractions or decimals, and those that cannot. Okay? So, we've been dealing with these all forever. So now, students, let me introduce you to the new group of numbers, imaginary numbers. Imaginary numbers. All right. So, y'all ready for imaginary numbers? Here we go. Before you write anything down, writing utensils down, look up to the screen, put your thinking cap on. Here it goes. If I was to ask you for the square root of 4, what would you say? Because we know to do a number times itself to give us that number. What's that number? The number 2. What if I said square root of 25? Because a number times itself gives us that. Okay. But what if I gave you this? Don't write it down, just think about it. What number times itself gives us negative 16? Talk it over to your neighbor. See if they can figure out what number times itself equals negative 16. All right. So, I heard good discussions, and I heard people say, there is none, dude. That is correct. There is no such number that times itself gives us a negative number. Therefore, we can't say that this is a real number. That's why it's known as an imaginary. But now we're going to transform it to write it as an imaginary. So, writing utensils down, look up to the screen. Let me show you first. Do you agree that square root of negative 16 is the same as square root of 16 times negative 1? Okay, you're just paying attention. Are we there? Okay. Do we know that square root of 16 is 4? Is that correct? And that leaves us with square root of negative 1. This square root of negative 1, since it's to the smallest amount, is what we're going to call the letter I. Tell your neighbor why I'm going to label that I. Because it's an imaginary. So I just bring the number 4 down. Students, I just converted this into an imaginary number. Copy that, please. Students, imaginary, imaginary, students. Woo, let's go. All right. Put the wiggles over here to the right. I'm going to give you another one so that you can rewrite it as an imaginary. Square root of negative 49. Square root of negative 49. All right, share your work with your neighbor to make sure they got that correct. Square root of negative 49, what does that become? All right, so we should have done what? Square root of 49 times negative 1, which is 7 times square root of negative 1, which is 7i. Hands if you got that. Okay, let's do one more, just to make sure we are solid with this. If this one fits in there, that's fine, or underneath, that's okay. I'm going to do square root of negative 81. Square root of negative 81. And by now, your noodle's already, like, with the answer. I get you. Just make sure you work it out. All right. Everyone, square root of negative 81 is 9i. That is correct, and you did the work. Yeah? All right. So let's make a note down here. Our note is as follows. I'm going to put that an imaginary number. The I represents what? The square root, yeah, an imaginary, but the square root of negative 1. Square root of negative 1. Anytime you see square root of negative 1, you're going to replace it with what? I. Students, imaginary, imaginary, students. Very simple. You're like, I got this, Q? Well, of course we got this. Next, one more set of numbers that we're going to be working with throughout the year. Ready? I'm not going to make an extra column. I did this at the bottom. I did a row that covers the entire table. All right, and underneath you're going to write complex numbers. Complex numbers. So there's your table, 2 columns, and then underneath, complex numbers. Now, I told you that I made up this table, right? Right? Because I think a little bit more in a logical sense to see if it transfers over. Now, check this out. What kind of numbers do we have on the left side over here? Real numbers. What kind of numbers do we have on the right? Imaginary. Complex are a combination of real with imaginary. Let me give you an example. If I was to write a number from my real side, what number do you think I would pick? 23, Michael Jordan. That is correct. Plus, I need one from the right side. I would say 4i. I just wrote a complex number. Woo, let's go. All right. Let me do another one. Here we go. Can I use pi? Yeah, because it's part of the real, so I'm going to write pi minus, and I just pick another imaginary number. Which one am I going to pick? I'll pick 7i. That's another complex. Are we getting the idea of what complexes are? Yes? So, with that said, you need to write your own. Write me a complex of your own. Make up a complex number. All right, turn to your neighbor, let them write your number in their table, and you write their number in your table. Exchange your complex numbers. All right, Fabian, what'd you get? Give us a complex. What is it? 2 minus 9i. Hands, if you agree that's a complex? Yeah, that is correct. Did we get the idea in regards to the different groups? Once again, real numbers, imaginary numbers, complex numbers, and this is how the school year is going to go. We're going to first start with real numbers. We're going to do a lot of stuff with it to get us ready. We're going to roll into imaginary. From there, we're going to get into complex. Okay? So, good intro? Yes, Mr. Q. All right, good. So, set that aside. Check this out. So, next thing's next. I'm going to cover two properties that I've been talking about, but now I'm going to formally introduce them to you. The first one that I've been talking about are zero pairs. That one's known as the additive inverse, and we know that it's a number a number adding it to its inverse, it's always zero. And I use it in several forms like so. And what did I say they were called? Zero pairs. Have we been using that? Yes. Okay. That's one property. The other property that I didn't introduce is called the identity property of addition. All it says is that if you get 0 and you add it to a number, the answer is that number that you added to 0. And you can use that with numbers, different ways, and so on and so forth. Okay? All right. Now, today's lesson, we said that we're going to simplify algebraic expressions. Before I get to algebraic, I'm going to get your noodle ready to understand the definition of algebraic. Okay? So here we go. Write your utensils down, look up to the screen. I'm going to give you 4 different examples of numerical expressions. Okay? As I'm writing them down, I want you to think this. What makes them numerical expressions? Ready? Here it goes. All of those are numerical expressions. If I was to ask you to take a picture and DM someone, what are you going to explain to them numerical expressions are? Numerical expressions are this. Talk it over to your neighbor. What are numerical expressions? What makes them up? All right, so I heard numbers. Did I hear numbers? Yes? Okay. What else do we see? Somebody said addition, subtraction, multiplication. What is that called? Operations. That's what makes up numerical expressions. Now let's make an observation of what we don't see there. What's missing from all those expressions that we don't see? What don't we see? Talk it over your name. What is missing? What don't we see? All right. Not included. I heard the equal sign. Yes, equal signs are not included. And another obvious one, no variables. No variables. That's why these are only known as what? Numerical. As soon as we drop in the variable, it's called something else. Think about the objective today. What was the main concept? Algebraic expression. Well, guess what? Algebraics are those, but now including what? Variables. We're like, what? I know, right? Now check this out. Let's see where we're at with our notes. Let me go back to that sheet right here. We have a table here, yes? Underneath, I want you to make a big Freyer model, which is that one over there, and it's going to look like this. Should cover the other half of your page. Yes, it's over there on the whiteboard. Underneath there. Now let me show you what it looks like in real. There it is. So we have on the top left definition, on the top right critical attributes, bottom left examples, on the bottom right non-examples. And every time we have a lesson, the main concept goes in the center. So we're covering what? Algebraic expressions. So I'm not even going to tell you the definition, but if I was to tell you the definition, what three things do we need to have in algebraic expressions? Tell you never the three things that for sure need to be in algebraic expressions. Yeah, very good. Expressions that contain variables, numbers, and operations. You write that down. Now, the numbers by themselves, without any variables next to them, are known as constants. You've probably heard that before, yes? Examples given, x plus 3, m minus 7, 2 times y, k divided by 5. So look at the definition one more time. Algebraic expressions are expressions that have what? Variables, numbers, and operations. Do we have that here in the examples? Yes, I do. All right, good. All right. Now I'm going to make it really obvious with non-examples. Ready? Look at the non-examples. Why are these not algebraic expressions? Look at them. Tell your neighbor the obvious reason why those are not algebraic expressions. What do they have, guys, on the non-examples? Equal signs or inequality symbols. Yes, as soon as they have that, they're no longer expressions. So watch. For critical attributes, what makes these what they are? Well, the first thing I'm going to write, hashtag no equal signs. What else? What makes algebraic expressions? What is so different from the other kind of expressions? Hashtag what? Variables. There's correct. Variables. How we doing? Good? All right? And last but not least, underneath that, I'm going to ask you to write example Q. I'm going to go over one example, just one example. Here we go. Negative 5x plus 3y plus 6x plus negative 6y. Anywhere on the bottom, that's fine. So, let's go through the process to make sure we got it. What is the first thing we check? Addition throughout. Do we have addition? Yes, yes, yes. Second thing we check, are there any zero pairs? Let's see. Is this a zero pair with that? No. But can we combine it? Negative 5x and positive 6x. Can we combine those? Yes. These can cancel how many of these? And we're left with 1x, positive. That is correct. And this one, 3y and negative 6y. These cancel 3 of those, and we're left with negative 3y. And that's how you're going to do your home plate. Have a good one, guys. Enjoy your home plate. This video will be uploaded at the end of the day. See you guys tomorrow. Bye. Don't forget to get your syllabus signed. Okay? Later.